Hello, parents. So let me quickly demonstrate how we use materials to show or teach children new concepts. Now, by the age 6 or 7, the child already knows the names of the shapes, but they are introduced to new concepts like sides or edges, of any given figure, and the corners. Right now, what we do in this kind of a concept is, we have them make these shapes. So these shapes are made out of, very simple materials like matchstick and some rubber tubes. Now, while making these, what becomes clear in the mind of a child is whenever I'm using a matchstick, it basically represents a side or an edge. And whenever I'm using a rubber tube, wherever I'm using a rubber tube, it essentially is a corner, right? So while making these shapes, it becomes very clear in the mind of a child that a triangle has three sides or three edges and three corners. And the same thing for a square is four sides and four corners. They can of course do this for more shapes, like say they can do it for pentagon, they can do it for hexagon. In fact, they can take it to one more level. They can create a total of six such squares and join them together with glue, and they can create a cube out of this. Or they can create four triangles, join them together, and they can create a pyramid out of this. And they can do the same kind of exercise. How many corners and how many edges do these 3D shapes have? So, a simple material like this, but it has been used in a very specific way to introduce new concept to the child. The second concept that I want to talk about is integers. When a child grows to 8 or 9 years old, they are introduced to concept of integers, and they face questions like these, and they get confused a lot of times when they see two different signs in the same in the same line, and they don't know how to tackle this. So for that, we have made a very simple game which uses this kind of a strip. Okay, so when we are introducing the chapter of integers, we don't even tell them that we are going to do a chapter on integers. Instead, we tell them that we are going to play a game. And this game is pretty simple. So say two players, A and B, are playing. Okay, A and B are playing, and you are A. And we are looking at how this game pans out for you right now. Okay, so I am B, yours is the first turn. So I will basically show you that I have two different colored dice in uh, two hands, right? What I'm going to do is I'm going to take these dice away from your view and shuffle them. Okay, so I have taken it away from you and I have shuffled the dice. You don't know now which hand has which dice, right? And now I would ask you, B is asking A, which hand do you want to select? Let's say you select this hand, okay? The one that you see on right hand side of the screen. And it turns out to be white dice. Now what it means is whenever a white dice is thrown, your player piece will move towards the fight side. Okay, and whenever a black dice is thrown, your player piece will move towards the black side. So let's see what happens for you. Let's say I'm rolling the die and I'm putting. So you got 6 points, right? So now your player piece, let's say yours is blue, it moves 6 steps towards the white side. 1, 2, 3, 4, 5, 6. Again, let's say I have played and it's your turn again, and I shuffle the dice and you say that again you want the right hand side hand. Okay, whatever dice is there in right hand side hand, and it turns out to be black. So Again, in your turn, you shuffle and place. Oh, we have a coincidence. We have 6 black. So what happens in this case is your player piece will start moving 6 times towards the black side. Okay, so 1, 2, 3, 4, 5, and 6. What has happened here, if the child plays for this game for 10 to 15 minutes in, in the classroom or at their home, they understand that this is very similar to a number line concept. The moment you introduce the concept of number line, it will become very easy for them to understand. The example that we saw, what happened, it was +6 -6, plus being a white die and minus being a black die. So it was +6 -6. And where is the player piece? It is back on 0. Same way, they can definitely solve these kind of questions that I had put earlier. So for them, let's say if we are talking about one player, for them, what this means is they are going 3 times, 1, 2, 3 on the black side, and they are coming back 1, 2, 3, 4 on the white side. So their answer is 1. Or let me see, I'll just bring it here. So let me see the second one. They were moving towards black twice, 1, 2, and then they got again more black. So 1, 2, 3, 4, 5, 6, and they land upon -8. So these kind of questions become very easy to solve when they understand this kind of a number line easily, and we have made sure that they learn easily using these kind of simple game. The third example I want to take is for are still more older kids, which is like 11 and 12 years old, and they are introduced to properties of a circle. Now I have a piece of circle here, and there is a very important property regarding the chord. Now any segment which joins 2 points of a circle is called as a chord. If it passes exactly from the center, then it is a special chord and it is called as a diameter. But for our purposes, any segment which passes through 2 points of a circle is called as a chord. Now there is a property that if I were to join the center, which is somewhere around here, okay, center of the circle with the chord in such a way that the segment which joins it exactly meets at the center of the chord. Okay, so I am joining the center of the circle with midpoint or center of the chord, and if that happens, then the angle formed by them is 90 degrees, right? So how can we prove this to a child? We have long elaborate written theorems to prove this, but we can show it very easily to a child using a actual physical circle. So the first task is to find where the center is. It is very simple. You just take any side of the circle. You keep the circle oriented anyway, and just simply fold it, open it, and do the same thing in any different way. What happens is we get two diameters, and we all know that diameter always passes. So there is this one diameter and there is this another diameter. They both are passing through this point, this intersection point, right? And that point is basically the point which is the center. Now it is very simple to join these two, but again we will not take a chance. What we are going to do, I'm going to fold it at the chord, and then I'm going to fold it again so that my chord exactly matches. So my chord is matching, and now whatever I have this edge here, that is passing through the center. So my My segment, which is connecting the center of circle with the midpoint of the chord, is this. And if the child measures this angle using a protractor, this turns out to be 90 degrees. And for the child, we have practically shown that how in a circle, the line connecting center to the midpoint of a chord always is 90 degrees. They can try with any number of chords on the same circle, and that makes the concept very clear in the mind of the child. So, thank you for listening. We hope that you understood, and you would understood not only the concepts but also would be understanding that the way to introduce these concepts in activity based manner really helps the child to understand the concepts much better. Thank you so much for your time.